Hello and welcome to this lesson on flame tests for identifying metal ions. In today's lesson, we will learn how to conduct flame tests, recognize the characteristic flame colors for common metal ions, and understand the limitations of flame tests. To set the stage, let's quickly recap what cations and anions are. Cations are positively charged ions formed when an atom loses one or more electrons. For example, when a sodium atom loses an electron, it becomes a sodium ion. On the other hand, anions are negatively charged ions, formed when an atom gains one or more electrons. For instance, when a chlorine atom gains an electron, it becomes a chloride ion. Ionic compounds, like sodium chloride, consist of these cations and anions bound together. We will explore how to test and identify these ions in compounds through various techniques to deepen our understanding of their properties and behaviors. By learning these identification methods, you'll gain essential skills in chemical analysis, allowing you to determine the composition of unknown substances accurately. Flame tests are a visually striking method used to identify metal cations based on the color they produce when heated in a flame. This method works by leveraging the fact that, when heated, the metal ion's electrons absorb energy and jump to higher energy levels. As the electrons return to their lower energy levels, they release energy in the form of light, with each metal ion emitting light at a specific wavelength, resulting in a characteristic color. This distinctive color allows us to identify the metal present in the sample. Note, you are not required to know the detailed explanation for your GCSEs. To conduct a flame test, you can simply dip a damp splint into the unknown solution and expose the splint to a roaring Bunsen flame. Lithium compounds produce a crimson flame. Sodium compounds result in a yellow flame. Potassium compounds produce a lilac flame. Calcium compounds result in an orange-red flame. Copper compounds produce a green flame. Remember to use the correct terms for the colors. For example, saying purple instead of lilac for potassium will not be accepted in your GCSE exams. While flame tests are quite useful, they have limitations, especially when a sample contains a mixture of metal ions. In such cases, some flame colors may be masked or obscured by others. For example, if a sample contains both sodium and potassium ions, the intense yellow flame produced by sodium can overpower the lilac flame of potassium. As a result, it may be difficult to detect the presence of potassium since the yellow color from sodium is so bright and dominant, masking the more subtle lilac flame. This limitation makes it challenging to identify all metal ions accurately in a mixed sample using just flame tests. We will later explore advanced techniques like flame emission spectroscopy, which can help mitigate these challenges by providing a more precise method of analysis. In today's lesson, we explored the identification of cations using flame tests. We learned how different metal ions emit characteristic colors when heated, and how these colors can help us identify the presence of specific metal ions in a sample. We outlined the procedure for conducting flame tests and understood the importance of using precise color terms. We also discussed the limitations of flame tests, especially when dealing with mixed samples. By mastering these concepts, you are equipped with fundamental skills in chemical analysis, paving the way for identifying cations and anions in more complex mixtures. Watch the rest of the GCSE Chemistry course at Sophos Education.